Okay, so we're going to look at graphing exponential functions. And once we finish with the base graph, so this is another one of those graphs that you're going to have to add to your catalog of basic functions. And then just like we did with our transformations unit, we're going to do all the transformations on the graph. Okay, so let's just start by graphing y equals 2 to the power of x. So just like you did in your warm-up, let's start with 0 here in the middle of our table and then put in some x values as they get larger and larger, and let's put in some negative ones as well. So 2 to the power of 0, anything to the power of 0 is 1. 2 to the power of 1 gives me 2. 2 to the power of 2, 2 cubed, 2 to the 4th. And going the other direction, if I have a negative exponent, it means flip the base. So it's 1/2. Negative exponent, flip the base, 1/2 squared. Negative exponent, flip the base, 1/2 cubed, etc. Okay, so starting here, we're going to plot this point. X is 0, y is 1. X is 1, y is 2. X is 2, y is 4. X is 3, y is 8. And x is 4, and I'm already way off the graph. And we can see that as x gets big, y gets big, and in fact we say it's growing exponentially. If x is -1, we're just estimating that, we've got 1/2. At -2, it's smaller, we've got 1/4. At -3, smaller still, it's 1/8. And as x approaches negative infinity, our y value is getting closer and closer to 0, which is what we mean when we say we've got a horizontal asymptote. Grab a ruler here and sketch that in. Okay, so right here along the x-axis, this horizontal asymptote, y equals 0. Okay, when you have a base that's bigger than 1, we have something called exponential growth. Here are the key properties that you're going to need to know about an exponential growth graph. So the domain, all reals. The range, you only get y values that are strictly greater than 0 out of that. You have one asymptote. It's horizontal. Y equals 0. And you will always have this y-intercept. Anything to the power of 0 gives you 1. Okay, so those 4 properties are key properties you need to know about this graph. Okay, the other graph that we're going to work with is what happens when you've got a base that's less than 1. And in fact, a little bit more particular than that, our base less than 1 but bigger than 0. Okay, so when we're doing exponential functions, we're never going to have a base of 1. We're never going to have a negative base. Okay. So let's do our table of values again, starting with a 0, 1, 2, 3, 4, -1, -2, -3, -4. So if x is 0, 1/2 to the power of 0, still 1. If x is 1, I've got 1/2 to the power of 1. Gives me 1/2. 1/2 squared gives me 1/4. 1/2 cubed gives me 1/8. 1/2 to the 4th gives me a 16th. What if I take 1/2 to the power of -1? It means flip the base. You get 2 to the power of 1. 2 to the power of -2. Flip the base. You get 2 squared. 2 cubed, 2 to the 4th, etc. Okay, so let's plot these points. Starting at x is 0, y is 1. X is 1, and I'm estimating y is 1/2. X is 2, we've got a quarter. We've got an eighth. We got a 16th. And we can see that now as x gets larger, our function gets closer and closer to 0, which is what's called a horizontal asymptote, right here along the y-axis. If x is -1, y is 2. If x is -3, y is 8. If x is -4, y is way up there. And when our function decreases as we move from left to right, then we call this exponential decay. You get exponential decay when your base is a positive proper fraction, a number between 0 and 1. Okay, just a little note. The base is never going to equal 1. We either say it's bigger than 1, you have exponential growth, or between 0 and 1, you have exponential decay. We never let it equal 1. Okay, here are the key properties for both of these exponential graphs. You can see you've still got a domain of all reals. You still have a range of y greater than 0. You still have that horizontal asymptote y equals 0, and you still have the same y-intercept. When x is 0, y is 1. So we're going to take it from here and do transformations.